Good day, everyone. My name is Tandy, and in this lesson, we are going to be talking about electric circuits. So this is for grade 12 learners who are doing physical sciences. I don't know, you can use this for revision, exam preparation, or if you're looking to learn more about electric circuits and understand a few concepts. So I'm going to be doing 4 videos in total. I'm gonna try to do 4 videos in total. So in the first part, we have 4 videos in total. The first video, which is this video that you're watching right now, we're going to be chatting about electric current, potential difference, resistance up until Ohm's law. So that is the first part of this video series that I'm going to be doing. And then in the second video, the one that I will post after this one, we're going to be talking about resistors connected in series as well as resistors that are connected in parallel. And then the third video is going to be about internal resistance of batteries. And the last video under electric circuits will then be a few examples. I'll take questions from previous question papers and work them out, and just to kind of give you guys to kind of reinforce what we have done in these last 3 videos, and to see how some questions are solved, and to get good marks, I guess. So I hope you guys have fun. I hope you guys enjoy this one. So what I'm gonna do is I'm gonna just remove myself from the screen, just my face. I think the only important thing here is my voice. So as you can see, like I've mentioned, in this video we're going to be talking about electrical current, we're going to be talking about potential difference of voltage, and then we're going to also be talking about resistance. And then in the next slide, that is when we talk about Ohm's law. So let's just start. You see on this slide we have here a circuit. So this is a schematic of how you draw a typical circuit in physics, in your physics class. So we're gonna start from the bottom and go up. Started from the bottom. So this is an electric circuit. So here we have a battery, says 5V battery, and then we have a light bulb. So I want you to imagine a normal light bulb in your house. Really does not look like one in my drawing, but yeah, so that is the light bulb essentially. And then you want to connect this light bulb to a battery. So this is a battery. There are many batteries. So this will be the positive terminal of the battery, and this will be the negative terminal. And on this battery, you read somewhere it's written 5V. That is a 5, looks like an 8, and that is a V. Believe it or not, that is a V. I don't have sophisticated equipment to be able to draw these things nicely, but I guess with time maybe I will be able to get like nice things, to be able to draw these pictures much better. But that is not the point. The point is that, so you have a light bulb, you want to connect it to a battery so that it can glow. Without connecting it, nothing is going to happen. So you get a wires, connecting wires, connect there from the positive terminal, and yay, all of a sudden this light bulb is going to glow. It's gonna go on. So this thing that I've drawn here, when you draw it in a physics class, when you draw it in class, this is how you draw it. So the symbol for a battery, that is the symbol for a battery, a straight line there. So this will be the positive terminal, and another line, a much shorter line. So you see here, this is the positive, it's longer, that line. So this will be the positive, and then this will be the negative, positive, negative. So this will be the positive terminal of your battery, the side, and this would be the negative terminal of your battery. And then to a light bulb is represented by this symbol here, just a circle, and then you draw X in it, X marks the spot. So that is your light bulb, and your goal is to connect the two so that this light bulb can glow. You know, you want to see in the dark. So good. When we do that, but then how? The question comes in how? What happens? Why does it not light when it's not connected to a battery, or there's no connection? What makes it? So from that, I think you can already understand there must be something that travels from the negative terminal, travels, gets to your finger, it glows up, and then it goes to the positive terminal of the battery. And that something is called charge. So that charge is an electron. So when we talk about this, we have electrons here moving from the negative part of the battery all the way, okay, that's not positive, that's a mistake, all the way to the positive thing, to the positive part of the battery. So these electrons here, because they are negatively charged, they see this positive charge this side, and then now they see that, oh, there's also a way for us to travel to be able to get to the other side, and we are very much attracted to that other side, to that positive side. So they will start traveling. They will start traveling. Your light will go off here, will go on, it will glow, and then there they go. So that movement, that flow of charge from the negative terminal of the battery to the positive terminal, the flow of charge, that is what we call current. So there is current flowing in your circuit. So there is current flow. But then here they say electric current. Apologize for that. How do I make this thing disappear? Hey, okay. So they say electric current is the rate of flow of charge. So electric current is the rate of flow of charge. So yeah, we know that current or charge is flowing, but then there's the word here, they're talking about the rate of flow of charge. So how does that come about? In an electric circuit, if you want to measure current, we use an electrical device that we represent with this symbol. It's called an ammeter. So an ammeter measures the current. It's normally just an electric device with a screen and a couple of buttons and things you can press, as well as somewhere where you can put a wire to connect it to the thing, to the electric circuit. So let's say you take this ammeter, you connect it to your circuit, and then on the screen you read something 1A. So that is 1 ampere. So ampere is the unit of measure of current. So you measure it. What that means is that when in this current, 1 coulomb of charge moves, so flows through the flow. So 1 coulomb of charge flows in the circuit per second. So every second in this circuit, there's always 1 coulomb of charge moving. If the reading on that ammeter is 1 ampere. So now the relationship between the equation that represents current is given by I equals to Q over T. And like I've said, current is measured in amperes, and then charge is measured in coulombs. So that charge is represented by Q. In our case, it is an electron. So that charge is measured in things. So we might say an electron with a charge of 1 coulomb. So we mean that, yeah, that charge has a charge of 1 coulomb here. That electron has a charge of 1 coulomb, and then the time is in circuit. So if you're given a charge, for an example, they say calculate the current in this circuit, and they have given you the charge and they've given you the time. So you must make sure that the time is in seconds, and the charge is in coulombs. Then you'll be able to calculate it. Okay, so the next thing that we're going to be talking about is potential difference, and as well as, I'm just going to remove these things, potential difference as well as, so how I like to explain to myself, how I like to explain potential difference to myself, and I hope from my explanation you'll be able, okay, quick, come on. Yes, so how I like to explain it to myself is that I will say, I want you to imagine in this circuit here. So I want you to imagine a situation. Think about this as a mountain. Think about this as a mountain that you have to climb. At the bottom, we have a rock. You have a rock at the bottom, but your goal is to get this rock here at the top. So this, I want to, you can imagine then this rock is to represent a charge, an electron that you're trying to move from this point in a circuit to another point in the circuit. So this is you. Let me draw you as well. This is you. So this is the legs, believe it or not, and then these are the arms, and you're trying to push this rock. But you realize, hey, I will have to climb a very high mountain to get it here. So you have to put in work. You have to roll up your sleeves and push, do work, do a lot of transfer, a lot of energy. Hey, just a lot of energy that you have to push in there, because there is something, this steepness, this hill that you must climb. This something, it is acting against you, trying to push this rock of yours up the mountain for whatever reason why you'd want to push a rock up the mountain. But yeah, so that steepness, that thing that is wanting to stop you, the climb is very high. I want you to imagine that as the resistance. It is acting against you, trying to push this rock up there. And I want you to imagine yourself as a source of energy. You can gather up enough energy in yourself to be able to push it. So you imagine yourself as the battery. You are a source of energy. You provide us with enough push to get this rock to climb up from here up to there. So this is the same thing that I want you to imagine. So after you've done, let's say you are able to do it, you are able to move this charge, this rock, this electron from one place to the next. After that, if we were to put in something here, we measure it. Let's say we measure it. You put something that is able to measure the work that you've done, all the sweat and tears that you've put into climb, and that energy that you transfer into pushing this, that value that you would get, we call that your potential to be able to push, that rock up this mountain. And the same thing happens also in a circuit. So in a circuit, when you're trying to move a charge from here up to here, so you think about a light bulb as a source of resistance that you need to overcome, and you need to do work, you need to transfer energy so that you're able to move from this point here, that charge is able to move it from this point here to the next point. And then that is what we call potential difference, or we call voltage. We call voltage. So we can measure potential difference using something called a voltmeter. It's also an electrical device with a screen, a few buttons, and somewhere where you can connect, and then you read a value perhaps there. So you can connect it here in parallel to your light bulb for us to be able to measure how much work is needed to be done to be able to move this charge here from here up to here, and then we will get a reading. And that reading, like I said, so potential difference is the energy transferred or work done when we move 1 coulomb of charge between 2 points in a circuit. And the equation that represents that is given by V equals to E over Q. So potential difference is measured in volts. E is the energy, which is measured in joules, and Q is the charge, and we've spoken about it, it's measured in coulombs. Or we can say the work done per unit charge. It's either the energy transferred per unit charge, or the energy or the work done per unit charge. So that is the work done, and then that is, so if you have a voltmeter, you connect it here to your light bulb or whatever, and then you read that value. Say you see it says 1 V, so you know that you need 1 joule of energy to move that charge from here up to here. And then the last thing on this slide we're going to talk about, we already touched upon it, is the resistance. Is that thing, that internal property, that thing, that stiffness of the mountains that opposes the flow of charge, that acts against you trying to move this rock up this mountain. And for you to be able to move that rock, work must be done. You must sweat a little bit. You must give in energy. You must call upon all the energies in the universe so that you can push it. So work must be done. So that is the resistance. It acts against the flow of charge. I hope that is clear. So all of these things, all of these nice things that I've described, I've talked about the resistance, which is a symbol R. So the resistance symbol R here, the potential difference symbol V, and the electric current with a symbol I. All of these things, they can be related. Where's my pen? Wait, okay, there it is. They can be related to one another. So this is the resistance, this is the current, and this is the voltage, the potential difference. All of these things can be related to each other, to one another, by Ohm's law. And Ohm's law states, it says electric current passing through a conductor is directly proportional to the potential difference across it, provided that the temperature remains constant. So if the temperature is constant in a conductor, then you will find that the ratio of the voltage over current is the same throughout. The only time that resistance is gonna change is if the temperature changes. So let's say we measure we measure the resistance at 25 degrees Celsius, as well as at 75 degrees. That's the only time you will see the difference. But then if we just measure it here at 25 degrees and we measure the ratio of the voltage over current over time, it will remain the same, that thing. I hope I'm making sense. So that direct relationship means that, you know, we have directly proportional. So let's say we have the current here, this is a graph. We have the current here, and then we have the voltage. So if this increases, this will increase, you know. So that is the relationship that we have to each other. I hope I'm making sense. So here we have an electric circuit. So we have a battery, as we described in the last slide. That is the symbol when you draw a battery. You have the connecting wires connecting the resistor to the battery, and the resistor now is a source of resistance. So when you draw a resistor in an electric circuit, this is the symbol that you use. So that symbol, that triangle, box, whatever, so that is the thing that you use. And then you know that current is going to be flowing from here. Conventional current is going to be flowing from the positive terminal to the negative terminal. Remember, then charge is from the negative to the positive. So always remember that. So I think in questions sometimes they will say conventional current. then you know good, conventional current is from positive to negative. But don't mistake it and think that charge moves from the positive to the negative. It's all actually the other way around. Conventional current just got stuck somewhere. So yeah, so you have that, you have the resistance, you have a source of resistance, and here work will have to be done to overcome this resistance for a charge to then be able to move from this point to this point here. So work has to be done. So that will be your potential difference. So let's say for an example, you are given the circuit and they give you the voltage in volts and they give you the current in amperes. They will then say, okay, calculate the resistance. And resistance is measured in ohms, and this is the symbol for it. Omega, yeah, it's a Greek letter omega if I'm not mistaken. So yeah, then you'll be able to calculate the resistance of your circuit. Yep, I think for today that is it for now. So like I said, part 2 of this lesson is going to be in another video where we're going to be talking about the resistors that are connected in series as well as in parallel. So you will then see how the current is affected, the voltage, and very interesting things, interesting properties when you change how this network of resistors. So I hope you enjoyed the video. I hope you learned a lot from it. I would say that if something was not clear, or if you feel like I need to explain something a little bit better, then please do not hesitate to leave your comments in the comment section, or yes, I think I'll also leave my email in the video description if you want to get in contact, so that we can explain something a little bit more. So yes, thank you so much for joining us. Remember to subscribe so that you will know when I post a new video. I'm gonna try to post videos every week. So that is my plan. So like I said, I'm only just starting out, but the plan is to essentially post a couple of videos weekly. Yes. Thank you so much for joining me.